Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. We have matrices A, B, C, and D with given sizes, and every entry is 1. Your job is to decide which expressions BA, ABD, DC, and AB plus C are even allowed by matrix rules. And for the allowed ones, find the output size and the actual matrix. For multiplication, the inner dimensions must match. If x is m by n and y is n by p, then xy exists and is m by p. For addition, the matrices must be exactly the same shape.
And because every entry is 1, any row-column dot product just counts how many ones get added.
Let's start with BA. B is 5 by 3, and A is 3 by 5, so the inner 3 and 3 match. This product is allowed. The result keeps the outer dimensions, 5 by 5. Any entry is a dot product between a length 3 row and a length 3 column, so there are 3 ones being added.
So every entry equals 3 dot.
So BA is a 5 by 5 matrix filled entirely with 3s. Now AB. A is 3 by 5, and B is 5 by 3. Inner dimensions 5 and 5 match, so AB is allowed. The result is 3 by 3. Each entry comes from a length 5 dot product, so we add 5 ones. That makes every entry equal to 5. So AB is a 3 by 3 matrix filled with 5s. For ABD, we can multiply in stages. A common clean path is first AB, then multiply by D. Since AB is 3 by 3 and D is 3 by 1, the inner 3 matches, so ABD is allowed. The output will be 3 by 1. Take any row of AB, it's 5, 5, 5, and dot it with D, which is all 1s. That sum is 15, so every entry is 15, giving a 3 by 1 column of 15s. Now DC. D is 3 by 1, and C is 5 by 1. For multiplication, the inner dimensions must match, but here that would mean 1 equals 5, which is impossible. So DC is not defined. For A, B plus C, we must first compute B plus C, but addition requires the same matrix size. Since 5 by 3 is not the same as 5 by 1, B plus C is impossible.
And if the inside isn't defined, the whole expression AB plus C is undefined too.
Here's the full result. BA, AB, and ABD are defined and give constant entry matrices because everything started as 1s. DC fails the inner dimension check, and B plus C fails the same size requirement, so AB plus C fails too. Keep those 3 ideas in mind. Match inner dimensions for products, match full sizes for sums, and all 1s matrices turn dot products into simple counting. Watch the next video to learn more, where we'll use these same dimension rules to predict sizes instantly and avoid common matrix operation traps.